Pseudocode is when you describe the flow of the program without getting bogged down in the details. So for example, we're going to write a description of a program, and then we're going to turn that into pseudocode. So the problem description. We make custom furniture. Desks costs $500 to make. Chairs cost $100. If they ask for oak, we add $100 to the cost of each item. If they ask for mahogany, we add $200 to the cost of each item. We want a program that will ask the user for how many chairs and how many desks and what kind of wood. Then print the total cost for the chairs and the total cost for the desks. This kind of outlines the logic, but not really. You know, this is the requirements. It doesn't describe really the logic. It doesn't describe the steps the program would take. It's not an algorithm. It's just requirements. So I'm going to change this word description to requirements. So there's always more than one way we can do things. But if we skip the idea of defining stuff or making functions or things like that, what's really the first thing that this program does?
Define how much their desk and chairs cost?
Well, yeah, but before we can determine how much the desks and the chairs cost, what do we need to know? Yeah, we need our input. What kinds of input does this program need? I think we're asking two things, or maybe even three. What kind of input does this program need?
Ask if they want a desk or a chair, and ask if it's oak or mahogany.
Right. So let's see if I can get a new one of these going. Oh, Notepad, you silly program, not letting me open two windows. But if I do it that way, you let me. Okay. So in general, we need to ask the user how many desks, how many chairs, and what kind of wood. Doesn't have to be in that order. Maybe it makes sense to ask them right off the bat. You know, we could get really complicated and let them pick desks of one kind of wood and chairs of the other kind, but the requirements don't specify that. Once we have that information, we can do some processing. We can calculate the cost per chair. I'm just kind of blue skying here because you could do this in one step or you could do it in two steps. Calculate the cost per desk. Calculate the cost of all chairs. Calculate the cost of all desks. And then display results. That's a lot closer to pseudocode. That's an algorithm description. If I was going to turn it into pseudocode, I would just do things like add the word display or print and add the word input to this thing. So this is pretty close to pseudocode here. I'm going to just copy this, paste it, and we're going to modify those statements to be pseudocode. Print how many desks. Input, what should we call that? Would be a good variable name for it. Not X or... we could use D or dnum or desknum or... Let's just go with D. Because then we can use C for chairs. So then we're going to print how many chairs. Input C. Now, knowing Python the way we do, we know we're going to have to convert those to numbers. But this is pseudocode, and pseudocode is for using in any kind of language. And in some languages, you wouldn't have to convert them. So I'm not going to add a D is equal to float D into the pseudocode. You could. Print what kind of wood. We probably ought to display some choices. Print oak or mahogany. I think we should add a third choice, pine, which is so cheap that we don't add anything, but I didn't mention that over here in the requirements, so I'm not going to add that here. And then we're going to input wood. So according to our requirements over here, how do we calculate the cost of a desk? Desks cost $500 to make, chairs cost $100, but then we modify those. So, how would we calculate the cost of a desk? It's that cost, and then what do we do to it to modify it?
Multiply it by the number that we say.
That would be the total number of desks. We want a per desk cost. The first thing we need to do is modify it by the wood. If they ask for oak, we're going to add 100 to it. If they ask for mahogany, where'd my number go? We add 200. Had a brain fart there, sorry. Phew. Okay. So the cost per chair. CPC, cost per chair, is equal to 500 plus, but we don't know what kind of material it is.
So plus.
So why don't we do this? Let's use an if statement. If wood is equal to oak, then it costs per chair plus equals 100. If the wood is equal to mahogany, why did I choose such a long word? Mahogany, the cost per chair is equal to 200. Now, I don't know a darn thing about furniture construction. I don't know whether oak or mahogany is rarer or costs more or whatever. Okay, so that's a good way to calculate the cost per chair, in my opinion. I'm going to just put that as a comment. We need to do the same thing for the cost per desk. According to our pseudocode over here, oh great. Well, I made a mistake, but it's easy to correct. How much do chairs really cost?
100.
100, so why did I put 500? There we go. Calculate the cost per desk. CPD, cost per desk, is equal to 500. And if the wood is equal to oak, cost per desk plus equals 100. If the wood is equal, and there's always more than one way to structure these things. If the wood is equal to mahogany, we add 200 to it. All right, now we know the cost per chair and the cost per desk. We can get the total pretty easily. So just like you said, to calculate the total cost, you multiply the number of chairs and the number of desks. So calculate the cost of all chairs. I'm going to make that a comment. total C for total chairs is equal to the number of chairs times the cost per chair.
You're missing an equal sign on the CPD mahogany.
Yes, thank you. I missed an equal sign up here. So the total desks is equal to what? The number of desks times the cost per desk. Then display results. Print chairs cost plus total C, or comma total C, whatever. Print desk costs total D. And we didn't actually specify that it should add those two things together, but we could. It's not in the requirements, but it wouldn't hurt. We could do a print total, comma, total C plus total D. I think that would have been kind of cool, but it wasn't in the requirements. Yeah, let's do that anyways, just to be cool. Okay, print total cost total C plus total D. All right, that's pretty good pseudocode. The textbooks will say that we should do things like put the word set in front of each calculation. I don't know. I'm just going to leave that off. So this winds up looking a lot like Python, but it's not really Python. The syntax for the input is completely wrong to be Python. You know, otherwise it does look a lot like Python. And this should have been a comment. All right, to flowchart this, we could do that pretty easily. I'll wait until I stop hearing typing. That doesn't mean you need to stop. That just I want to wait till everybody's got this part in if you're typing it in. Okay. So here's our pseudocode. I'm going to kind of tuck that over to the side. Going into lucid chart. So what do all of our pseudocodes, flowcharts begin with?
Start.
Yeah, we're going to put a start. If it was a function definition, you'd put DEF up here, but you're still going to have some main code with a start in it. So there's no functions in this, although we could try to break it up into functions. It's not necessary. Then what's the next thing our pseudocode does? Yeah, we're going to ask. Which do we ask for first? The number of chairs? And yeah, doesn't really matter, but but I'm going to make it match our pseudocode.
The first one was how many desks?
So I would make a print statement or a display statement, how many desks, and then I would use an input statement. That's totally wrong. There we go. Input D. If I wanted to make it look more like Python, I would say D is equal to input parentheses. Either's cool.
Can you put them in the same box?
We could, but I'm going to try to discourage people from putting things in the same box from now on, because I had people on the exam like cram 8 different statements into a box.
Okay.
It's like, no, that's going overboard. The only things you should put in a single box combining are when you're doing print and input, because you can do that in a single statement in Python, or if you're doing several assignments, initializations. And what I mean by that is if you do x is equal to 3, and then pi is equal to 3.14, and then max is equal to 10. Those are all the same kind of thing, so it's okay to put all that in the same math block. But otherwise, don't mix up more than one statement in a block. Print and input's okay, but don't put all the prints and inputs in one block, just each pair. And sure, you save 10 seconds by, or 30 seconds by putting them in a block, but then you get points off on the exam if you don't get the right one. So print how many chairs. And then input C. Alrighty. Now realistically, I need to start drawing lines, but I'm just going to draw a line from here to here and then send that line to the back. That makes it look okay. What's next after we've gotten our input? So after our input, we do our processing. That's going to be the calculations. Which calculation did we do first?
It was the cost per chair.
Okay, yeah.
Wait. No, we asked.
Oh, we had to ask what kind of wood.
What kind of wood?
Right. Okay. Print what kind of wood? Parentheses, oak or mahogany.
Does that go before the chairs?
It could. When we're getting our input, you can pick, the order that makes the most sense to you. Honestly, that's probably a good thing to do. And it would be kind of cool if we let them pick, one for each kind of thing they're ordering. But we didn't do that. And so we're entering that in a variable called wood. Now we're ready for the processing. Usually I just keep making things scroll all the way down, but I think in order to get more on the screen at the same time, I'm actually going to start a new column, and so I'm going to put a line going from the bottom of this one to the top of the other.
Would you use the little circle thing?
I could. I could put a circle at the bottom and then a circle back up at the top. That's one way to do it. Another is just to draw a line going back up. So let's see. I've already forgotten. Were we calculating the cost of the chair or the desk first?
Doing the desk first.
Okay.
On the pseudocode, we're doing the chair first.
All right. Well, Here we ask for the number of desks first. Maybe we should calculate the number of, or we can make it match exactly to pseudocode. So that is math. Prints and inputs are all in rhombuses, but math is done in blocks. So we're going to calculate the cost per desk. Cost per desk is equal to, now here's the kind of thing that it would be acceptable to put more than one in the same block because we are initializing variables. 500 per desk, and how much were the chairs? 100? The only reason I'm letting these go into one block is because they're practically the same. They are equivalent operations. We are just initializing these variables. But now we need some if statements. If it's wood, we're going to add something to the desk, and if it's wood, we're going to add something to the CPC. Now, if we go back to our pseudocode, we could make the pseudocode more efficient. And the reason we could do that is because our code looks something like this. If wood is equal to oak, then the cost per desk increases by 100. And then we do if wood is equal to mahogany, then the cost per desk plus equals 200. And then we do if wood is equal to oak, then the cost per chair plus equals 100, and then we do if wood is equal to mahogany, then the cost per chair plus equals 200. Based on what we've seen in the past, and it's okay if you don't know, but is there a better way of structuring this so that we could only use 2 if statements rather than 4?
If wood equals oak, CPC and CPD.
Exactly. Why do 2 if checks when we could do 1 if check, and if it's oak, we increase both CPD and CPC? So, this would be a better way of putting it in our flowchart. And it'd be easier to, that would have been better in our pseudocode, and it would be easier to flowchart it as well. So, I think I'm going to go back and modify my pseudocode to match. That kind of messes up our comments, but that's kind of easier to fix. Calculate the cost per items. I'm going to move CPD is equal to 500 up above our if statements. And then I'm going to change our if statements so that if both operations that happen if it's wood are grouped, and both operations that happen if they're mahogany are grouped. I hope that makes sense. It's kind of, if it makes it easier to draw, it probably makes it easier to program. Okay, going back over here. If statements are done in decision blocks. Now, in the Python language, strings are actually enclosed in quotes. So I'm going to go ahead and do that even though it wasn't in the pseudocode. It probably would have been nice to go ahead and put it in the pseudocode because this is true pretty much of all programming languages. But still, if it's oak, the yes side is going to go over and we're going to do some math. The cost per desk goes up by 100. And this would be one where it would be feasible to put them both in the same block because they're very similar operations thematically. And the cost per chair goes up by 100. And we didn't put an else statement, so we don't need anything going off to the right.
Couldn't we put, if it's not oak, it's mahogany, so then the no statement could be, it's
That would be a good idea. We could put an else and then put the mahogany ones, but then later on, if we went and added pine and who knows what else, then the logic starts breaking down there. So that's a very good point. The suggestion was, why don't we put the no side and then add the 200s on, making oak the special case that decides whether it's 100 or 200. And the reason I'm suggesting we don't do that is because later on we might want to add other kinds of wood. I'm going to get rid of this A in the middle of the circle. The A just serves as a place for the if statements to hook back up. All right, now we need another block that's going to look very similar. Notice the only difference? Well, not the only difference. But if this is a while, instead of hooking down to a circle like that, it would go back up here. And everybody did that pretty well on the exam. Everybody who actually drew a while loop. A few people skipped that. It's going to look so similar that I'm actually just going to copy and paste. I'm going to select all four of those things. Control C for copy. Control V for paste. Put that down underneath it. And then change this to mahogany. And change the numbers. There's another way we could structure this. I don't want to keep throwing options at you, but we could just calculate the extra cost. We could say extra is equal to 100, and then we could do else, or extra is equal to 200, and then change the cost per chair and the cost per desk underneath that. Alrighty, that's pretty good. Now we just need to print our results. Oh, I forgot to draw a line from here to here after talking about that. Let's do that. You could do that, or you could do one of those, end circle here and beginning circle there. I think this is easier. It just takes fewer steps, but you could do it like this. You could say A here. I don't care which one of these you actually do. Whoopsie. Put another one up at the top. And then, but that's more steps to do it that way. But you get the idea. I like seeing the lines myself, so I'm going to undo those changes. All right, the third column is where we print the output. So print, we seem to have been going desks first and then chairs. No, I can't say that yeah. Print, total for desks, comma. Oh, I haven't done the calculations for the totals. Didn't we do that in our pseudocode, do the calculations first?
Yeah.
We did total, like it's total C equals C times.
Yeah, let's do that. So, remind me what our variable name for total desk was.
Total D.
Okay, total D
All one word equals like
is equal to the number of D times the cost per D. And then the total per chair is equal to the number of chairs times the cost per chair. And then we can do our prints. Now I'm going to need to draw a line all the way from here, all the way up to there. From that circle up to here. Just because we don't want any dead ends. Now we can do our prints. We've done our calculations. Print total cost for chairs, for desks, comma, total D. And then I did a copy and paste to save myself some time. Total cost per chairs is equal to total C. Not equal to, comma, total C. And then we decided it would be awesome to print the total, which was total D plus total C. Remember, if you hit Control Enter, it forces a line break. So if you can't get it to all fit in one block, or you get tired of resizing them, then you can do that. And that's it. We can put our stop there. Now you could have written this program based on the pseudocode, but flowcharting it gave us additional insight into it. For example, it gave us the idea of combining these two math operations under one if statement and these two maths. So we get a better idea for it. Which is more important? Well, it's certainly easier to pseudocode than it is to flowchart. Okay, so I'm going to come up with a problem that I'm going to want y'all to do the pseudocode and the flowchart for. It's going to be a homework assignment, but since, we still have 20 minutes in class or whatever, you could elect to work on it in here. Let's make a Dropbox for these things, and then I'll tell you what the homework is. Oh, just as a reminder of our reminder, any PY script you write should have comments with your name and the assignment number and the description of the program does. And I'd like for it if you went ahead and did these two things as well. A comment next to the variables and a comment next to the major parts of the program. Like this. Get input from user. Ask how many desks. That kind of stuff. What is C? It's the number of desks. What is D? It's the number of, that kind of thing. This explains the program to somebody who doesn't understand programmerese, and it helps you later if 2 years later you have to come back and modify it. Anyways, Dropbox. This is in class 10. Desks and chairs. Pseudocode and flowchart. Alright, so you can do a download as, and get a PDF for your flowchart and put it into Dropbox 10 in class 10. And if you would save your pseudocode, if you wrote it up, I hope you did. You won't get counted off, but I wish you did. And put it into there as well. And I'll put the pseudocode and the flowchart myself in the notes. Okay, this program's going to seem awfully similar, but that's okay. It's just a drilly concept set. We are a maker of custom rings and bracelets. we charge a base cost of $50 per ring and $200 per bracelet. If they ask for gold, it's $300 extra. If they ask for silver, it's $200 extra. And we're going to get wacky and add a third choice. If they ask for brass, it's $100 extra. Ask the user for the number of rings and the number of bracelets. Calculate the cost per ring. Calculate the cost per bracelet. Calculate the total for rings. Calculate the total for bracelets. Display the totals. So that's the logic, that's the requirements. And the assignment itself is to do a pseudocode and a flowchart for this. And what I would hope that you do, that you don't do, is just do a copy and paste of all your text and then change some things. And the same for the flowchart. I'd rather you do it by hand because you'll burn it into your brain better. And this will be homework 4. All right, gang, that's our goal. Feel free to stay like 17 minutes and work on it or whatever. I'd like for you to use your time, but if you're going to run off, I won't condemn you for it. Yeah, sure. I'll be right back there.
Yeah, I put, oh, I don't know why I put D. But I was looking at my other one, like comparing it, I put D.
Yeah.
Oh my
D is
God.
the number of rings. Sure, why not?
Sure, that makes sense. This is logic, right?
I forgot to make this a stop here. My mistake.